Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. Information about it is at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today, for July 8, 2018. Problem number 20 from the last exam MLC in the multiple choice section. XYZ offers a pension plan with the following lump sum death in service benefits payable immediately on death. $10,000 for each full year of service on death in service between ages 64 and 65, and $15,000 for each full year of service on death in service between ages 65 and 66. You are given that death is assumed to occur halfway through the year of age. Decrements for this pension plan follow the illustrative service table. Interest rate is 5%. XYZ uses the traditional unit credit funding method. Calculate the normal cost for this benefit for a new employee who is age 50. Since this is a new employee, the initial accrued liability is 0. Also note that the normal cost for this employee for the first year of service is unaffected by death during the first year of service because there is no death benefit for death in service between age 50 and 51. Also, salary increases are irrelevant for the benefits, and by the way, it's also for future years until the death in service happens in those prescribed years that we have in the text of the problem. And also salary increases are irrelevant for the benefits in this plan, so there is no difference between projected unit credit and traditional unit credit. And we can use the standard recursive formula for projected unit credit with no mid-year exits, which is that the initial accrued liability plus normal cost is equal to the actual present value of the accrued liability at the end of the period. And normally you'd also add the actual present value of mid-year exits. But since the initial accrued liability is 0, we simply have C1 equals 1.05 to a negative 1 times P50 times 1V. Of course, this just means that the normal cost is the actual present value of the sum of $10,000 for each full year of service on death in service between ages 64 and 65, and $15,000 for each full year of service on death in service between ages 65 and 66. In other words, this normal cost which is 1.05 to a negative 1 times P50 times 1V, is equal to the actual present value of those death benefits, which are paid either in the amount of $10,000 at the age 64.5, so $10,000 discounted at 5%, times the number of deaths at age 64 divided by L50. That would give the actual present value of those deaths between ages 64 and 65, and then in other words, the normal cost, C1, is the actual present value of that accrued liability a year from now, but it's simply the actual present value of the $10,000 benefit paid at death in service between ages 64 and 65, paid at age 64.5 in the middle of the year, which is the first quantity in the numerator. It accounts for that. It counts the death, and then it's divided by L50, so it amounts to be a probability of the death, and it's the amount of the benefit discounted, plus $15,000 paid for death in service upon reaching age 65, and paid at age 65.5 in the middle of the year. I know it's strange, but that's the way the problem is set up. So anyway, you might want to ask the question, how do they know that somebody's going to die at age 65.8 and then pay in advance at age 65.5. Not relevant because the problem tells you to do what the formula says here. And then it's the $15,000 benefit discounted with the probability being D65D divided by L50 and the discount factor being 1.05 to the negative 65.5 minus 50. We look up the numbers D64D in the illustrative service table, and we get 257 for that. The number of deaths at age 65 in the illustrative service table is 204, and the population size at age 50 is 29,919. So once we plug in all those numbers and do the calculation, we get C1 to be approximately 90.35, which is answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.